Hi, welcome to my video on the remainder theorem part 2. Just some different questions on the remainder theorem to help you think and use the property of the remainder theorem. If the p of x equals negative 2x squared plus 3x minus 4, find the p of negative 2. So the p of negative 2 equals negative 2. X is negative 2, so we sub it in the place of x. And we do our power first to get a 4. And I do all the powers first, done. Then I multiply and left to right, multiply and divide left to right, so that's negative 8, negative 6, minus 4. And then we finish it off by adding them up and getting a negative 18. So notice the p of a is the remainder. So what we just worked out is that if you took, that's the p of negative 2, so that's an x plus 2. So if I took this polynomial and divided it by x plus 2, then I would get a remainder of 18. Negative 18, sorry. And don't forget to pause the video and work these out before I do. And hopefully, as I try not to make any errors, but I normally make some slight errors. When this polynomial is divided by x plus 1, the remainder is negative 10. Find the value of k. So we have a divisor called x plus 1. So that means in that divisor that a is negative 1, because it's the opposite of what the constant is in your divisor. And we know that the remainder is negative 10. So we also know, or should know, that p of a is equal to the remainder. So that means that the p of a, negative 1, is equal to negative 10. So if the p of x is equal to 4x cubed plus 3x squared plus kx minus 2, which is this polynomial here, that means the p of negative 1 is 4 negative 1 cubed plus 3 negative 1 squared plus k, x is negative 1 minus 2. So the p of negative 1 is negative 10, so I put that in. And I work out my powers first, so negative 1 cubed is negative 1. Negative 1 squared is 1. And so, notice I did my powers first. So now I'll do my multiplication and division left to right, so it's negative 4 plus 3 minus k, subtract 2. And what I do, I simplify each side of the equation as far as I can, because then I'll have less to transpose. So negative k, and that's a negative 1, minus 2 is negative 3. So let's go over here, and we bring the k to the left to make it positive, and we bring the negative 10 to the right to make it positive. So k equals 7. So if you put 7 back in here and divide x plus 1 into this polynomial, you'll get a remainder of a negative 10. Or if you do synthetic division, which is negative 1, and like this, negative 1, and this is a 4, 3, k is 7, so it's a 4, 3, 7, negative 2. Draw a line, bring down your 4. That's a negative 4 when I multiply. Add negative 1, multiply 1. That gives me an 8. So that gives me negative 1 times 8 is negative 8. And I add and I get negative 10. So that's the remainder. That's just, I use synthetic division to check to see if the k for 7 is correct, which you can do. Number 3, when the p of x is divided by x minus 3, The quotient is x squared plus x minus 4, and the remainder is 6. Find the p of x. Well, the p of x is equal to the d of x times the q of x, which is plus the d of x is your divisor, the q of x is your quotient, and right here I used to call this the r of x, but a lot of books and teachers just say that's the remainder. That's going to be a constant. So the p of x is equal to the divisor is x minus 3. The quotient is x squared plus x minus 4 plus the remainder of add on 6. And we multiply this out. So x times x squared, x cubed, x times x is x squared, x times negative 4, negative 4x. Now we're going to multiply negative 3 by these three. Negative 3 times x squared, negative 3x squared. Negative 3 times x, negative 3x. Negative 3 times negative 4 is a plus 12. And add on 6. And descending order is x squared, x cubed first. And that's a 1, and that's a negative 3, so that's a negative 2x squared. Negative 4x and negative 3x is negative 7x. And 12 and 6 makes 18, so that's the polynomial. That when divided by x minus 3 gives you a quotient of this trinomial here and a remainder. And that's the answer, but let's just check. We're dividing by x minus 3, so we do 3. It's a division on 1, negative 2, negative 7, and 18. Draw a line. 1, 3 times 1 is 3. Add 1, multiply 3, add 4, multiply negative 12, add 6. And notice, you'll see this coming up later, that this, again, this is the remainder here, and the remainder is 6. But notice that this is 1x squared plus 1x minus 4. So that 1x squared, that's right there. That plus 1, that's right there. That minus 4. So the coefficients of this trinomial are the coefficients that end up here. But you'll see that coming up later. Okay, let's try another one. When this polynomial is divided by x minus 1, the remainder is 2. When it's divided by x plus 1, the remainder is negative 16. Find the values of k and g. So we got 2 to do. It's got to set up 2 equations because we got 2 different bits of information here and make them equal and solve them. So what we have a divisor right here, which is x minus 1. So that means that a is 1. The remainder for that divisor is 2. So that means that we have the p of x is equal to the polynomial, which is x cubed minus k x squared plus gx minus 5. And we also know that the p of a is equal to the remainder. So that means a is 1, so the p of 1 is equal to 2. So the p of 1 equals, let's put 1 in the place of x. 1 goes in the place of x. And the p of 1 is 2. And we simplify this expression. So we have 1 cubed is 1, and we have negative k, 1 squared is 1. So I just did the powers first. And now I'm going back and make that a negative k plus g minus 5. So 2 equals negative k plus g minus 4. So let's move the variables. K to the left makes it positive. G to the left makes it negative. And is equal to negative 4 minus bring the 2 over, make it a minus. So k minus g equals negative 6. So we have one equation, call it number 1. Now let's do when it's divided by x plus 1, remainder is negative 16. So the divisor is x plus 1. That means a is negative 1. And the remainder is negative 16. And again, the p of a is equal to the remainder. So that means the p of, make that a p, the p of a negative 1 is equal to negative 16. So the polynomial p of x is, write all this down again, so it's x cubed minus kx squared plus gx minus 5. So the p of negative 1, so we have the sub negative 1 in the place of x. And that's done. And now so the p of negative 1 is negative 16. Negative 1 cubed is negative 1. Negative 1 squared is 1. And again, I'm just doing the exponents first. Now we'll go back and do the multiplication. Negative k, negative g, minus 5. There's a 5 there. Negative 16 equals negative k minus g. And that gives me negative 6. So bring the k to the left, make it positive. G to the left and make it positive. And that's negative 6 plus 16. So k plus g equals 10. That's equation 2. So let's take the two equations. K minus g equals negative 6. And k plus g equals 10. And notice we have a system of equations with two variables. So that's positive, that's a negative g, positive g. So we draw a line, add them up, and they cancel. So 2k equals 4. Divide by 2. So k comes out to be 2. Now, this sub k equals 2 into number 2. So k plus g equals 10. K is 2. So 2 plus g equals 10. G equals 10 minus 2. So g is 8. So k is 2, g is 8, and that's the two values that we put back in here. So if you put k here to make this negative 2, you put g here to make it 8, and you did synthetic division, I'll just check one now. Synthetic division with 1. See if we're right. I'll use the synthetic division to check. So that's a 1. K is 2, so that's negative 2. G is 8, so that's an 8. And negative 5. Draw a line, bring down your 1. 1 times 1 is 1, add negative 1. 1 times negative 1 is negative 1, add is 7. 1 times 7 is 7, add 2. So again, there's your remainder right there, which is 2. And again, it just shows that k is 2, g is 8 is the correct values to make this true. I did this one. So I could, if I want, do synthetic division with negative 1 into this, and I would get 2 also. Okay, let's continue. And number 5, when this polynomial is divided by x plus 2, the remainder is negative 33. Find the values of k. Notice k is here and here. So what we'll do, we have a divisor of x plus 2, so that means a is negative 2. So the remainder is negative 33. So the p of a equals the remainder. So that means the p of negative 2 is equal to negative 33. So let's write down the p of x is equal to this, polynomial here. So it's 4x cubed plus kx squared plus k squared x minus 1. So the p of negative 2, so just be careful, put negative 2 in the place of x. Negative 2 goes in the place of x. And negative 2 goes in the place of x. Done. And we simplify. So the p of negative 2 is negative 33. So we get 4. So that's negative 8 when we cube it. And we get negative 2 squared is 4. And we get k squared. So notice the only thing I did was I did the cube and the square. Now I'm going back and call that negative 32. So I'm multiplying right here. I'm multiplying here. 4k. I'm multiplying here. And negative 1. So let's simplify the right side. So I get 4k minus 2k squared minus 33. Negative 32, negative 1, negative. And you notice that that's a negative 33, and that's negative 33. So that means that I'm going to take the 2k squared, move it to the left, make it positive. Take the 4k, move it to the left to make it negative. And that's equal to 0. And I have a quadratic, so I'm going to factor. I see a 2k common, GCF. 2k squared divided by 2k is k. Negative 4k divided by 2k is negative 2. So I have a quadratic, so I have 2k is equal to 0, or k minus 2 is equal to 0. Divide by 2, k is 0, and k is 2. So there's two values for k that will fit in this equation. And if you want, you can put this k into the equation. So 4x cubed, k is 0, so that's gone. K is 0, so that's gone. Minus 1 is your polynomial. So this is one of the polynomials that you could have, but I just said find k, so I found these two answers. So I'm just doing this as extra. So the other polynomial is when I put 2 in for k. So 4x cubed, and it says k is 2, so it's plus 2x squared. K is 2, so 2 squared is 4, plus 4x minus 1. So these are the values of k that will make this true to give you a remainder of 33. But what I'm going to do is check. So if I take this divisor, which is negative 2, opposite of this, and I put this polynomial in, so I get a 4. Notice there's no x squared. Notice there's no x. Minus 1. Bring down your 4. Negative 8. Add. Multiply. 16. Add. 16. Multiply. Negative 32. And it adds up to be negative 33. Perfect. That's your remainder. So we know that 0 for k is okay. And let's see if this one is okay. So we're going to do negative 2, because my divisor is x plus 2. I've got a minus 2. So we'll take 4, 2, 4, negative 1. And bring down the 4, multiply, negative 8. Add, negative 6, multiply, 12. That's 16. Multiply, negative 32, negative 33. And that's a remainder also. So there's two values of k, and I just checked it to show you that I'm checking with synthetic division here. I'm dividing by the negative 2 in synthetic division and got the remainder of negative 33 twice. So 0 for k and 2 for k are the two answers that make this true. So again, just some extra questions to keep you thinking. I'm always reviewing the math skills, because we did a system of linear equations, and here they are back in this polynomial on doing the remainder theorem. And if you like my video, click the like buttons. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.